Alright, so now we are looking at percentage yield. Okay, so please make sure you do these questions before you watch this video. So just now we said that percentage purity we are looking at reactants. Percentage yield we are looking at products. Because we can calculate that we assume we get this amount of product, but then actually we get lesser. Okay, so let's look at this question. Calculate the percentage yield looking at products if on heating 50 grams of limestone calcium carbonate, 21 grams of lime were obtained. So let's circle this. This is my actual yield. So what you need to do is to calculate the calculated yield. So question mark gram. What mass of calcium oxide should I get if I start with 50 grams of calcium carbonate? Alright, so let's do that calculation. So I need to go down, find out the number of moles of calcium carbonate, go across, find the number of moles of calcium oxide, and then find out the mass of calcium oxide. Okay, so step 1, find the number of moles of calcium carbonate is equals to 50 divided by the MR is 100, 40 plus 12 plus 3 times 16. So this is 0.5 moles. The mole ratio is 1:1. 0.5 mole is to 0.5 mole. Right? And then after that, to find the mass of calcium oxide is equal to 0.5 moles times the MR, which is 40 plus 16. So that's 56. So I believe no brain power now, times 56, that's 28 grams. So now I would have calculated to form 28 grams, but I only form 21 grams. So the percentage yield is what I get actually 21 grams divided what I calculated. Okay, remembering that it cannot be more than 100%. Okay, so 21, 28, and that is 21 divided by 28, that is 75% yield. So that means my reaction is only about 75% efficient. Okay, so remember two things. One, percentage yield must be products, right? You're finding towards products, and the information given in the question is actually the actual yield. Okay, let's look at the next question. Calcium oxide is heated, formed by heating calcium in excess oxygen, shown below. If 2.2 grams of calcium was used, 2.2 grams, 2.9 calcium oxide was produced, calculate percentage yield. So remember, when you talk about yield, we are talking about products. So this one given is the actual yield. So we need to find out what's the calculated yield. We take actual yield divided by calculated yield. So question mark gram over here, and we have 2.2 grams, go down, calculate number of moles, go across, calculate number of moles, and then go up. This percent is grams. Okay, so let's try. So step 1, okay, remember divide your page. Step 1, number of moles of calcium is equals to 2.2 grams divided by AR. Alright, and AR for this one would be just 40. So let's calculate that. 2.2 divided by 40, and I get 0.055 mole. Okay, so by mole ratio, step 2, 2Ca is to 2CaO. So it's 1:1 ratio. So 0.055 mole. Okay, so then I need to calculate what is the calculated mass that I should get from calcium oxide. So that's equal to 0.055 times the MR, which is 40 plus 16, what we did just now. Okay, so 0.55 times 56 again, that is 3.08 grams. So I have calculated that I should get 3.08 grams, but I only got 2.9, right? So the percentage yield is equals to actual 2.9 divided by calculated 3.08 times 100%. So 2.9 divided by 3.8. No, wrong. 2.9 divided by 3.08. That is equals to 94.2% yield. So that's the percentage yield. Well, when you work in a chemical company, we'll always want to make sure that our yield is as high as possible and the purity of our product is as good as possible. So that's why calculating percentage yield is very important. Okay, now last question. Okay, ammonia is manufactured from the reaction of hydrogen and ammonia. Now, there's no chemical reaction, so we need to write the chemical reaction now. So hydrogen is H2. Please remember magical 7 and the hydrogen H2 plus nitrogen, which is N2, will form ammonia. Please remember what's the formula of ammonia? NH3. Okay, now we need to balance this equation. So this equation, I have 2 nitrogens on my left side. I also need 2 nitrogens on my right side. I have 6 hydrogens now on my right side. I need to have 6 hydrogens on my left side. I already have 2, so I just need times 3. So let's check. I have 6 hydrogens, 6 hydrogens, 2 nitrogens, 2 nitrogens. Okay, so now let's write. I want to find percentage yield, so remind myself, percentage yield is for products. Okay, percentage yield is for products. So over here, question mark, grams for products. So over here, my 5.1 gram, this is my actual yield. Right, so I start with 28 grams of nitrogen. Be careful where you write it. And I need to go down, find the number of moles, go across, find the number of moles, and then go up. Okay, so now let's take a look. So I need to go step 1, divide my page, find the number of moles of nitrogen. Although nitrogen is a gas, I don't divide by 24 because this is mass. So 28 divided by 14 times 2, which is the MR, and that is 1. Okay, mole ratio of nitrogen 1:2, NH3 is 1:2 moles. Quite straightforward. And then I need to find the mass of ammonia, NH3. That will be 2 times 14 plus 3. That is 1734 grams. So my calculated yield is 34, but I only get 5.1. So my percentage yield is equals to 5.1 divided by 34 times 100%. So let's calculate that. 5.1 divided by 34, that is 15% yield. Now this is what we call the Haber process, and usually, the yield is quite low, right? So this is a realistic number. Okay, so again, percentage yield, what we must take note of is that percentage yield is referring to products, and the number that they give you here is the actual yield. Alright, so I hope that has been useful, and hope you can understand this. Alright.